look at something mentally much easier, okay? Did I not open it? Sorry. No, wrong one. Center of gravity is what I wanted. Now there's a lot of slides, but there's a lot of pictures. So it's really, there's not too much in this one, okay? And if we don't get it finished, we'll just continue it the next time. So, center of gravity, that's what we're having a look at now. Okay, center of gravity. Right, let's have a look at what we have here. So, maybe some people actually know this word center of gravity already. Does anyone know it?
Like the center of the earth?
Well, a bit more general than a particular example.
Center of anything.
A center of a thing.
Exact.
Yeah, close. So, look, the way the center of gravity is, when you have a mass and there's a weight pulling it down, the center of gravity is where the weight acts on your diagram, where you draw it. So usually, Adnan, that is the exact center of the object. So for example, if it's a square, the center of gravity is right in the middle. If it's a circle, it's right in the middle. But if you have something like a triangle, it would, like if I draw a triangle like this,
It would be lifted down.
yeah, it'd be kind of more like here, wouldn't it? Now, we all kind of understand what center of gravity is from our day-to-day life. The center of gravity of this is where the weight acts. You can find that with your finger. It's the point where you can balance it. Yeah. So, you know, it's basically where the gravity force acts. It's the single point through which the full weight of a body appears to act. So the center of gravity is basically where the weight force vector acts. In other words, it's on my picture, it's where I draw the weight. Okay, so this is the formal definition here, please. I want to write this down. It's where the weight appears to act. Got that? Okay. I think I need to continue. Appears to act. You got it? Appears to act, yep. Okay, continuing. CG is just center of gravity, or COG. You were trying to express yourself saying that it's like the midpoint or it's the center or something. So another way to think of it is it's like the average mass point. It's getting a bit technical though, and we don't really need that for the exam. It's just where the weight acts, is the simplest way to put it. Okay, so if you were to look at these three people walking, who is most likely to fall over? Who do you think? In other words, who is the most likely person that if someone was to just about fall, who is it going to be?
The left one.
No.
A. No.
A.
First one.
The first one, A.
Why?
Well, because
High
Carrying a baby.
Yeah, yes, yeah. The reason is the center of gravity is much higher for this person. So if you think about it like this, when you're driving in a car around the corner, okay, if the car is very tall, or like a bus,
Yeah.
does that feel like it's more likely to fall over than the car? Yeah. In other words, when the center of gravity is high above the ground, it makes things more likely to fall over. So if you're designing something and you want it not to fall, you place the center of gravity low. Examples: Formula 1, F1 car. You know F1, Formula 1?
Mhm.
Those cars are very low. That is so that they're less likely to fall over, to topple. Yeah. So in other words, center of gravity is important for stability. High center of gravity means you're more likely to fall. Okay. So the answer here is A for the first one. Okay. And the Y center of gravity, the higher it is, the more unstable it is, because remember it's like
Something like.
if the weight force is acting high. Yeah, it's basically a big car. It's like a big Jeep. It's a very high car. And if you go too fast in these around a corner, then off the road it goes. So center of gravity for an engineering point of view is very important. Okay?
How about it? Okay.
I think the airplane is quite balanced. The center of gravity, I think, is kind of in the middle. I think it's in the middle,
Sometimes.
in between the wings. It should be the same level as the wings, I think. Yeah, because if you put it above or below the wings, then I think you'll start making the plane unstable, I think. Right. So this is just a bit of vocabulary. Fulcrum is another word for turning point or pivot.
But this is,
I don't know. Look! And you see, I even have the arrow from last year when I drew it on the door. And this is a fulcrum. It means a point that turns, a turning point. These are just synonyms, okay? I like to use this one, turning point, because I think it describes what it is. But you may hear or see it as a pivot or as a fulcrum. Okay, so like here in the window, if you look here, let me see where the turning point is. So it's, where is it? It's like somewhere here. So this is in the center here, the fulcrum. Oh wait, this is broken. Oh, nice.
And
Yeah. These would be pivots, turning points, fulcrum. Okay. So it's the point at which an object turns. For example, the hinge on a door. Another example, the center of a seesaw. You know that toy the children are on, and the wheels in contact on the road. So the wheel of a car on a road, there's a turning point in the center there of the wheel. Yeah. And is there any more examples? Oh yeah, your foot on the ground actually, because if you look, when you put your foot down to walk, there is a turning effect when you walk. So this is also a turning point as well. Okay. Right, can you write the definition down, please? You have it? Great. Right, so this one here, notice how the center of gravity is above the turning point. And the base, her hands are very small. So she is the most likely person today to fall over. Her center of gravity is high and her hands are very small. So she could easily fall. Now, let's look at a coffee cup. Center of gravity, what do you think? Kind of in the middle, isn't it? So it's a little high. But will it easily fall like the gymnast?
Small, no.
Not, yeah, It's not too bad because the base is kind of big for the size. Huh? What, Mir?
No, it will fall down.
Well, if you knock it.
Ask Mahmood.
Mahmoud has a story for you.
Oh, you'll have to tell me sometime then. Okay, of course, if you knock it hard, it will fall down, but it won't fall down by itself,
Yeah.
right?
Yeah.
Because the base is big enough for it. You know, if you made the base smaller, would it be more likely to fall down by itself? Yeah. So here, the center of gravity is above the turning point, but the base is rather big, so it could fall, but not easily. You need to give it some force. Right, now, I don't know if you remember this toy as a kid. You remember it, nice.
Yeah.
You had it one?
No.
You didn't have this toy. It was a great toy. It was an eagle, and the center of gravity of the eagle was on its beak. So it meant you could hold the eagle toy on your finger at its beak. So you see here, that's like its beak.
Like football, like you.
Like with a football, yeah.
Okay, yeah.
So it could look like you're perfectly balancing it. So here the center of gravity is exactly at the turning point. You had this toy.
Yeah.
Yeah, and you had this
Yeah.
toy. Did you have this toy?
No.
No? No, I had this toy. Okay. I'll have to find one for you. So here, the center of gravity is at the turning point, the beak. So even if a little force is applied, it may wiggle or move. So what was nice about this is with the bird on the finger, and it's balanced, center of gravity is on the finger, you could give it a little wiggle and it just move a little bit, but it should stay where it is. It shouldn't fall off. Now, of course, if you hit it hard enough, it will. Right, now, he is hanging from a bar, and his center of gravity is below the turning point. So he is actually very stable, because even if I hit him, all that he'll do is just wiggle back and forth on the bar and then come back to rest. Okay? And again, his hands are quite small, so he shouldn't fall easily. This is the most stable object we have. The center of gravity is below the turning point, so if you hit it, all that happens is it moves back and forth, but does it fall? No, it doesn't fall. And also the base is quite big. So for example here, this is quite big, isn't it? So it shouldn't fall or it shouldn't break. Now if this was quite small, like if I had a little piece here and a little piece here, and if I hit it hard enough, then it will, yeah. So my point is, we have two factors to consider when we decide how stable something is, which I don't think I put into a table. No, I didn't. So what I'll do is, I think we'll finish on this point and then continue the next time. So there are two things you need to care about when you want to know how stable something is. The first one is the center of gravity much higher than the turning point. Does this make it stable or unstable?
Higher.
Yeah, it's high, it's unstable. If the center of gravity is at the turning point, like the eagle, then it's kind of balanced. And if the center of gravity is below, then it's very stable. Yeah, so the example my physics teacher used to gave me is the man on the rope. So if the man is standing on the rope, he is unstable while his center of gravity is above the turning point. If he's hanging from the rope, he's actually quite stable because little movements aren't going to be a problem. Here a movement will be a problem. And then if he is on the rope and he gets knocked, he'll just maybe wiggle a little bit, but it's actually okay. And then the other thing is how big the base is. That's the other factor. So for example, this and this, both of them, the center of gravity is quite high, so they are unstable. But which is worse? Worse. First one, yeah. So the base, the size of the base is very important. Okay, so I think what we'll do is we'll make a little table, and you can write this table down. So we have two possibilities for the base. We can have a big base or a small base. And the center of gravity, we have three possibilities. What are they? Center of gravity can be high, above the turning point, or below the turning point, or on the turning point. Right, so first situation, high center of gravity and big base. So what would we say? Is it unstable? Yeah, it's kind of hard. It's unstable because it could fall, but it's not too bad because the big base helps it. So it's unstable, but still it would be hard to fall. But it could fall, right? Like the coffee cup in your story you're going to tell me sometime. Right, big base and center of gravity is below. Well, this is stable. In fact, it's very stable. And center of gravity on the turning point and a big base, this is like okay. You know, you can maybe wiggle a little bit. Small base and center of gravity is high. Very unstable. Small base and center of gravity is below. This is stable, but it could break. Since the base is small, it could break. So it could break. And lastly, small base and center of gravity is on the turning point. This is okay. So now that you know this, think about the Formula 1 car. Okay? Is the center of gravity high or low? It's low. Is the base big or small?
Big.
It's very big because the Formula 1 car is very wide. It's very wide and it's very low. This makes it very stable. Give me a vehicle that would be very unstable, that the center of gravity is higher and it's the base is quite small. The base is small. No, the base is kind of big for that. Motorcycle. The base for the motorcycle is quite small. It's just a little rectangle. It's not like a wide car. So you have a small base, and because you're sitting on it, your center of gravity is quite high. So then this means motorcycles are easy to fall down. But of course, and they are. Jet ski. The base is quite big for a jet ski, so I think it's okay. Yeah. Now, to finish, let's talk about people. So, base, big or small?
Big.
No, I don't think so, because it's only my 2 feet.
Yeah.
And this is quite small base. And my center of gravity is quite high. So, are people stable or unstable? No, unstable.
People are unstable.
They're unstable. It's easy for you to fall down. And the reason you don't is because your brain is very capable of balancing yourself.
If a child.
Exactly, a child knows it's unstable. This is why it's so difficult to make robots that walk. Okay? Because it's very unstable. The robot will have small feet and high center of gravity.
And they don't have brain.
They don't have a brain as good as people. Yeah. So, do you understand with the robots, they fall down a lot because they're unstable. And it's only because of our brain that makes us balance. Yeah. But if we weren't alive, if I was just like a plastic mannequin, a small push and down I go. It's because I can counteract any force that makes me stable. Okay. So we'll continue this next time. It's mostly just definitions for the first half. I think this is okay. Please really try that question for homework.
Yeah, sure.
Really try it.